This question was asked in GATE 2019 Electronics and Communication Engineering paper, in which you have given a random process y of t, which is described by h of t convolution with some other random process x of t and plus z of t, where this x of t is a white noise process with PhD x of f, and this h of t represents the filter whose magnitude response is given by magnitude of h of f, and z of t is a stationary random process which is uncorrelated with x of t. So you need to find out the power in random process y of t. So the NPTEL reference for this question is Probability and Random Variables by Professor Aditya Jagannatham. So the useful data for this question is that if we have a given random variable z equal to x plus y, then you can write this autocorrelation function rzz of tau, which is equals to rxx of tau plus ryy of tau plus rxy of tau plus ry of x of tau. So if x and y are uncorrelated, then rxy tau is equal to ryx tau is equal to 0. So if x and y are uncorrelated, then this value will be 0. So your rzz of tau will be given by only rxx tau plus ryy tau. So this is your first condition, and the Fourier transform of this autocorrelation function will give you the PST, that is S of Z of F, PST of this random process Z of T. Also, the one more condition, it is 1 and it is 2. One more condition is that if you have given a random process y1 of t, which is defined as h1 of t convolution with x1 of t, where x1t is a random process and y1t is also a random process, and h1t as a impulse filter response. So you can write this in PhD form as sy1 of f is equal to magnitude of h1 of f square s of x1 of f. So this is your relation in PhD form. So in the question you have given y of t is equal to h of t convolution with x of t plus z of t, where x of t has PhD, that is x of f is equal to 5 watt per hertz. Also, you have given the magnitude response of the filter, that is h of f is 0.5 from -5 to 5. Z of t is your stationary random process, which is uncorrelated to uncorrelated to x of t. So now let's assume w of t as h of t convolution with x of t. So you can write s of w of f in the PhD form from the useful data slide. This one is h of f square into s of x of f. So if you put w of t as h of t convolution with x of t, then your y of t becomes w of t plus z of t. This z of t is uncorrelated to x of t. So this z of t will be also uncorrelated to w of t. So you can write r yy of tau as r ww of tau plus r zz tau, because z of t is uncorrelated to x of t, so z of t is uncorrelated to w of t also. And in the PhD, taking the Fourier transform, you can write sy of f equal to sw of f plus s of z of f. So this is in PhD form by taking the Fourier transform of this autocorrelation equation. So now you have sy of f, that is PhD of phi of t random process, which is sw of f plus sz of f. Also, s of w of f is given by this equation, which is magnitude of h of f whole square into s of x of f plus s of z of f. So h of f is defined by 0.5, that is magnitude is 0.5 from -5 to 5, where this is your h of f and this is your f axis. This is magnitude h of f. So s of x of f will be multiplied by this 0.5 square, because the magnitude of h of f square will be 0.5 square into 5 plus this s of zf as given in the question, which is -5 to 5 and magnitude as 1. So you can write this one as -5 to 5 and this one as -1, sorry, +1. This one as +1. So this is your total PhD, that is sy of f, which is represented by adding these PhD and adding this PhD. So the area under PhD will give you the power in that random process. So if you need to find out the power in the random process y of t, then you can find the area under this PhD and area under this PhD, and by adding them you will get power in the random process y of t. So the area under PhD will give you the power in that random process, So you have given this PhD sy f S of y of f as summation of these two PST. So if you can find the area under this PST and area under this PST, and by adding them you will get power in y of t, power in y of t, which will be given by this area of the rectangle, which is equal to 10 into 1.25, that is length into width, plus this one as 5 into 1, that is the area of triangle. So you will get answer as 17.5 watt. So the answer for this question is 17.5.